Welcome to the stream. Is there anything you'd like to talk about today? Or do we just continue from where we left off?
I think we can continue. How about you, William?
Yes, I can continue.
Okay.
Right. So last time we looked at this handle node function for the get rule follow set, and basically refactored it where it now doesn't need a local from the enclosing function. So this big match statement can now be separated into methods on the individual classes. But before that, I wanted to do one more thing, and that's to simplify the signature, because right now this function returns 2 values, and I think that could be reduced to just 1. So do you know what get rule follow set does? So basically we return a set of all tokens that might follow the given named rule in the grammar. Right? Yes, tokens are terminals. So token is a lexing term and terminal is a grammar term, but when those two are connected together, they're the same thing. So tokens are terminals, the rules are non-terminals, and we go through all the rules, the entire grammar, and look at all the nodes recursively, basically. And when we find this non-terminal with the proper rule name, then we return true. And true here means, well, it's not in the docstring anymore, but true here means that the next, like this the tokens that the next thing can start with can follow that rule, right? So let's actually bring back the old docstring here before I added this to do. So right now the function returns a pair where the first element is true if the follow set of this node should be included in the result, and then a set of tokens that should be included in the result regardless. Does that make sense? All right. So how do we do that? So let's say this handle node. So for the previous refactoring, I basically split this into several functions, one with the old signature and one with the new signature, and then I incrementally moved the code between those two. So I think I'll do that same thing here as well. So I'll name this handle node old, and each of the recursive invocations will I'll change to that, and then I'll have the new handle node which will have the new doc string. Right. And now I basically need to convert between the old and new. So to handle node, I call the old function, and then if include follow is set, then I return tokens to include with none included. Otherwise, I just return tokens to include. Right. I hope that makes sense. So include follow is this, right? Let's name it. Okay. And I'll try to. Excuse me?
It's a great doc string. It's a great doc string. I like that.
Please, maybe you have the wrong microphone set up because you were kind of staticky and a bit distant.
Oh, okay. Yes. I can fix that. Thank you. Thank you.
Yeah, I couldn't understand what you said right there.
Okay, go ahead. No problem.
Sorry. Well, what I'll do now is basically move all of these one by one to the new function. And I'll start with something easy, like this thing. So for these cases, I will want to call this handle node, and no, let's do it in this case, right? So for anything else here that's not covered in these cases, I will want to call handle node. And then if the result includes none, then I want to return true and the result without the none. Otherwise, I want to return false and the result, right? Well, I want to convert calls to one function to calls to the other function, right? And I'm doing that because I don't want to rewrite this whole thing at once. I want to do individual chunks of it and run the tests or run the process each time. Right, so this is a bit of setup there. And now I take this case and I put it in here. So right, so this case is now handled in here, and I don't return false and set, I just return the set. That should be the new be the new return value. And I'm getting infinite recursion on line 1 to 70 right here. Calling handle node, and that's going to handle node old. Oh, I should match not the class but the variable. Right, so this works, and now I can do the same thing for all the other cases and test each one. Does that make sense? Right, so non-terminal here. If the value is in rule name, then I return a set with none in it, which means the following tokens need to be included. Otherwise, it's the empty set. Well, still it works as before. So I can go to gather, and gather is a bit more complicated. So gather only works if the separator is a simple token, or is a token.
Okay, question. Wouldn't it be similar to, like, not parse class, but to read if you just did as simple as instance check instead of a full match for that?
Yeah, I guess. So, yeah, this is set up for more cases in the future, basically.
Yeah, fair. That's fair. That's fair.
Right now, yeah, I didn't know how many of these would be needed. It turns out it's just one, but I guess you could have a more complicated gather, which then would need some more complicated logic and probably its own tests. Yeah, but let's rewrite it. Okay. So, right, now the problem is that I'm returning stuff here that I don't want. I haven't finished rewriting this. So now I handle the node. So I handle the item. And include follow, that means if none is in the tokens for item, then I get the start tokens for the separator. Right, so none in tokens for item means I should return the tokens that should follow the item. So I get the tokens for the separator. And if the separator can be empty, that's not implemented yet. Otherwise, I return, so this is true, which means I wanted to have none in the result. So I know there is none in tokens for items, so I don't need to get rid of it here. Be like that. Otherwise, false means I don't want none in the tokens for item, which I don't, so I just return this. Hopefully that'll work as before. Does that make sense? Is it easier to follow? Or is it just complicated in both versions?
I'm sorry, I was reading lazy spot. Can you repeat that? So something complicated? What was it?
So, does this make it easier to follow, or is it just complicated in both cases?
Let's see. Yeah, I don't think it's ever gonna be simple.
Right.
And it's difficult to judge if it's better or worse because there's less skills in the match. So it's gonna appear simpler either way.
Right.
Short, I don't know.
I guess the sequence, when we get to it, will be the worst to follow. Well, that's why I'm saving it for last. Okay, now we have a choice. There's a flag for include follow. And in the new convention, the flag for include follow is done by including none in the return set, right? And what we do here is we handle each alternative in the choice, look for the tokens it can start with, and put them all in the result.
I just understood what the none is doing there, and I'm not sure I agree yet. Like, I'd rather have a pair instead of a magic defense suicide. Just personal opinion, of course, but I don't think that none, like, at least define a special object or something instead of, I don't know.
Okay.
I don't know, I'm sorry, I only just understood what the none is doing, and I'm not a big fan.
Right. But at least you understood it.
Yes,
So,
a bit late.
okay, so let me follow through here and then look at the result. And if we don't like it, we'll probably want to change the get possible start tokens, which uses the same convention currently. So we can revert. So right now, basically the none stands for include whatever comes after. So it kind of fits in the set. We can call handle node here. And
Do it ourselves, include the follow set directly.
Which follow set? So none means the follow set of the node we are currently handling, which we don't really have access to. But since the flag is kind of included in the set here, it's a bit less complicated.
Yeah, ultimately it's not bad, but it's like if you don't read the doc string.
Oh well, if you don't read the doc string, you're just completely lost, I think.
Yeah, but like if you don't read the doc string, there's two values. You know that there's two pieces of information that are being returned, right? If you don't read the doc string, when there's only one return value, you assume the return value is complete, at least to me.
Well, this, yeah, you can compare it to the pair that's, you know, the first one says whether the value is complete, and the other one says
Yeah.
the other one is like the possibly incomplete value. And the other one is, you know, there's a special value that says replace this.
Yeah, honestly, I'm not a big fan, but if you feel like that's the best path, I'm not gonna oppose.
I'm trying to figure it out. I mean, this one is quite elegant.
Let me see the tiny yes.
Right, since none works like a member of the set, yeah, you can just do set operations.
Yeah, I suppose. Yeah, I see where you're coming from. Just
Still didn't convince you.
again, it's just personal opinion at the end of the day.
Don't worry, we can always revert it. I just want to see how it works in the end. So now we have.
I'm not telling you, hang on, I'm not telling you to straight up revert it. I'm just sharing my concerns.
Yeah.
Like, you can ignore me if you want. I won't mind.
Like I said, I want to see this to the end and then compare with the other option. Because if we do revert this, then we want to do the same thing for the get possible star tokens. And that also uses none for basically a flag. So this include follow will be replaced by none in the tokens well, let's call it tokens for item. And then if there is none, then we need to add the possible start tokens for the item itself. Right. And now we have true here, which means we need to include the none. False here means we don't want the none in the result. So in the end, again, I mean fewer lines of code. Mainly because none again works as a special member of the set, right? It just gets replaced with whatever comes after. Right. Optional should be easy in both cases. And that leaves us with sequence here. Where we track this add to follow set, which will convert to having none in the result. and here we have the result. So this include follow we can remove, because tokens to include now have none if the follow should be included. This can be replaced by if none is already in the result. And now if there is no none in the start tokens, that means the following node cannot match an empty string, which means we break this for loop here.
This is a bit convoluted, in my opinion.
Yes.
Like, anytime there's a for else, I always feel like there could be some chain of flow.
Okay, let's analyze it a bit better. Okay, so maybe we should get rid maybe we should put it in the alt place and get rid of this for else. This is probably too complicated.
Maybe replacing one of the for loops, the while, would make it clearer? I'm not sure, I'm just guessing. Because a while you're not forced into the next iteration. I'm not sure.
Or maybe we want to rewrite this entirely.
Yeah.
So we have a sequence of items and we want to return a set of all tokens that might follow the given rule, right? So,
An accumulator set, right?
excuse me?
We probably need an accumulator set.
Yes.
Yeah.
And that will be an empty set in the beginning, right? And then we go through all the items.
Maybe if we did two passes instead of a single one.
I think that's what we did here, actually.
Kind of. It's quadratic. It's not two passes. I'm thinking two linear passes.
Yeah, let's see, what do we do here? So this function handle node returns a set of tokens that should be included in the result, right? So we include, so we need to call this recursively like this. And that, you know, if
Hang on, no, hang on. We need to save this into a temporary variable. Check if none is in every single one of them. Like, we don't need to save every one. We just need to check if none was in every iteration of this. And if so, we
right.
also include none. What is the empty string again? Do you follow? Am I crazy?
So this would be like like the basic thing, and now we need to handle the none, right?
Is it the like? Is it? No, we need to handle the empty string, right? Because we wanted to know if the empty string can be in full set. Oh, is that what? Oh, I see. That's why none is a magic constant. None is the empty. Okay, that makes a lot more sense. Yeah. Okay. Yeah. Now I'm on board. I'm a bit slow today. Pardon.
So here none means that the follow set of the node should be added to the result, which,
Yeah,
I mean, if we get it here, that means the follow set of the item should be added to the result, which basically means, well, I think we can keep it in the result.
it would just be harder to check if it's a new none or if it's a previously existing.
Because if it's a previously existing none, we need to clear it.
Yes. Discard? Is that the move? Okay.
Yeah, discard is remove without an error.
Interesting.
Right, there's, I think, remove, which errors out if it's not already there. But I seem to always use discard instead. Right, so now if tokens for item includes a none, then it will be added to the result. And if none is there in the result, just before this, that means the follows, that means, like, if here none is in the result now after this update, then that means the initial tokens from the next thing should be added to the result, right?
Yes.
And that's what we're doing here. I mean, afterwards none remains in the result, so that means the next thing after the whole sequence will be included. But if the next thing is the next thing in sequence, that puts it up here in the next iteration of the loop. And if that's the case, then we need to get the possible start tokens. That's some bad naming here, but okay. And we need to add those to the result. And we only keep the none if tokens for item included. Otherwise we remove it. Whoa, it actually works. And that's some pretty convoluted logic.
Yeah, I'm still not sure I understand the two separate discards and that. It feels like one of them should be in a different set. I just need some time to process the logic. I see, because then the tokens for item would be in
Yeah. Maybe that's too much of a shortcut.
I think it just needs comments. The logic is fine. It just there's a few leaps that I don't know.
Alright.
I think comments would be
So we can remove the old handle node here and basically okay. Alright, so now we have a simplified signature of handle node. Do you think we should add comments to this, or should we go back to the old thing with the flag?
I think this is shorter and therefore has like that other one has a nested for loop, right? This is, I think, measurably simpler.
Well, I
Just
think
not
we
simple enough.
can remove the nested for loop from the other one. If I press Ctrl Z enough times, I probably want to start with what I had before. So we have a result, and we should have a flag there, and we should only go through the items. Don't think we need this mess here. So we definitely add the how was this? Definitely add the tokens to include the result.
didn't feel natural until that clicked.
Okay. Let's leave that for later.
Yes, yeah.
Is this it? Yeah, so this also needs a single pass. So this would be the original calling convention with the flag, and this would be the new one. So in this case, the old one is actually a bit shorter. I guess the new one can be simplified as well. So, what do you think? Can we stick with this one? With the comment you mentioned?
I personally like the new one better because it.
Okay.
I mean, both are fine.
Oh, we do need to connect this. So this can be simplified a bit more by discarding none in here and not in here. Now result is only updated here and then here. So if we always discard it afterwards, it should work, hopefully. Yeah. And I think what this needs now is a lot of comments and some better variable names.
I think I am a bit lost again. Let me flip it a little bit while you write comments. Right, yes, yeah, I can
Right. can't be up here. It should. No, let's not do that. This makes sense. Does that make more sense? Maybe this follows set. Let's reword that. Okay, do we need any more comments here? And now, do we make this into methods of the individual classes? I guess the advantage of having it all here is that the doc string is right next to it. If we move it to, like, if we move this handle node to individual classes, then I guess it would need to go in a node. Somewhere here. Don't need rules or rules considered down there, do we? Just need the rule name. We do need rules. But we can get rules from the grammar, and rules considers is in the outer, so we just need rule name. Know how to word this. So it returns a set of all tokens that might follow the given rule inside this node, or if that rule matches part of this node, I don't know. make sense? It's a lot more complicated than I would like, but I don't think I can simplify that right now. So let's now put this handle node as a temporary variable that should take self and this rule name. This node should be replaced by self. I guess we can put back the not implemented error down here instead of calling handle node old. And now this will be what getRuleFollow set will return. And now instead of handle node, we do item.handleNode rule name. It. And instead of a handle node, we need to call it getRuleFollowSet. This rules, which is a variable here, the rules should be the rules should be passed recursively. There's also rules considered. Oh no, the rules considered is outside this recursive call. So for the rules, I can use self.grammar.rules, hopefully. Error. Do nodes have a grammar? They do not. Oh, that needs to be passed in. Okay. Oh, well, yeah, to all the constructors in here. Well, I mean, currently the methods take a rule dictionary, so I guess that would be a separate refactoring. Right, that works. And now I can put these individual parts in individual methods. Right, so instead of case, I put in this def and I copy them wherever they're needed. So for sequence, I take this thing, go to the definition of sequence and plop it in here. For optional, go to the definition of optional and plop it in here. For 0 or more and 1 or more, now maybe they should share a superclass. Let's see. Yes, a decorator node. So that's a node with exactly one child. So they have the precedence in common. I guess they could have the format in common if this becomes a parameter. One's a plus, the other one's a star. I hope I'm not refactoring too much. I can't run tests right now because this is not proper grammar. So let's plop this in for choice as well. For gather, for non-terminal, and then for base token, negative look ahead and positive look ahead. So that's both of the look aheads. Oh, definitely. Thank you for helping, and see you next week. Oh, I see. So I got rid of the cases here, but they contain important information, so these are also variable assignments that I need to re-add. So here this item would need to be self dot item. The value needs to be self.value. The item here also needs to be self.item. Alt, oh, self.alt, right? Is it self.items? And here it's self.separator, I hope. Self.separator and self.item. Where's the item here? Right, so that works. I think I need to put an additional none here. No, I don't. It all works. And I guess this getRowFollowSet global function can now go on the grammar. Where is the grammar here? So instead of rules, this will have self. Need to call it on the grammar. Oh, but I'm not passing the grammar. Right. Okay, so one more refactoring before that. Blaze, are you still here? Guess not. That was a bit confusing. Anyway, one more refactoring before that is, I guess, each node should have a reference to its grammar. So I decorate the nodes as data classes. Every time we create a node, we'll want to add the grammar to it, but that will complicate things, because now whenever we want to match on a node, we'll need to put the grammar inside the match here. That's not very nice. Can data classes do something like do a field that's ignored in matching? I don't know. Let's see what data classes can do. Field can have a default factory init, repr hash, compare, metadata. What's metadata? Third-party extension mechanism. And then there's keyword only. So nothing that could prevent a field from being matched. So there's match args. If true, the match args tuple will be created from the list of parameters to the generated init method, even if init is not generated. If false or match args is already defined in the class, then it will not be generated. So we probably will need, so if nodes are to have a reference to their grammar, then we'll need to create a custom data class decorator. That might be fun. So I think that should work like this. Yep. And I guess it could either be a decorator or a superclass or a meta class. Let's see what data classes can do. Data classes can create a new data class. Data classes can, right here, a decorator used to add generated special methods. So I guess this this will update a class. Can we call the data class decorator from inside init subclass. So there's this init subclass method which is called whenever a class is subclassed. So this could automatically apply the data class decorator to all subclasses of node. But I'm not sure if that will actually work. Is there a way to get fields? Yeah, that... I don't think any magic there would help. Let's add a special decorator that applies the data class decorator to a given class. And what I want to do here is to remove grammar from the match arguments. But let's see how far I can get with just this. So whenever a node is created, it needs a grammar, which unfortunately means I cannot use singletons like this because I don't have a grammar yet. I'll need to do some other way. So remove those, and now I just go by the errors and see where I need to pass in the grammar. So I need to pass the grammar to convert gen node. And it looks like I need to do that before the grammar is created. Yeah, this is this is too convoluted, I think. So I would basically need to create the grammar in here, pass it into here, but not grammar. So I mean this self to here. But then the snippets get created too late and it all breaks down. So I don't think I can actually add the grammar to nodes. I need to pass it through every time I do something recursive. So no simplification there. Each one of these recursive function now takes rules. It can take a path, it can take rules, whatever other arguments it needs. But yeah, most of them take rules. And that's it. Maybe I could combine rules and path together. I guess we're in pretty good shape here. And the next thing to do is what is the next thing to do? Go through the to-dos, stop refactoring for now, and do some functionality. And I guess the most important thing to do is improve the line wrapping. So if we go somewhere like here, we need to make a better line wrapping algorithm. And I still haven't really read up on anything about line wrapping. I wonder where I would start. So I guess a good precedent to look into would be how Black does line wrapping. So there's the tool called Black that can format Python code in relatively nice style. I think it had some explanation of the algorithm. Current Black code style is described here. How Black wraps lines. So Black will ignore previous formatting and apply uniform horizontal and vertical white space. So it tries to render one full expression or simple statement per line. If this fits in the allotted length, great. Yeah, that's I guess that's good to start with. So if anything we want formatted fits on one line, it'll stay on one line. Otherwise, Black will look at the contents of the first outer matching brackets and put that in a separate indented line. I don't think we can use that directly because we don't always have brackets in the grammar, but I guess we could pretend that there are brackets around expressions. Okay, if that still doesn't fit the bill, it will decompose the internal expression using the same rule. What does that mean? Like it looks at brackets, puts the contents of the brackets on a separate line, and the brackets themselves before and after, and hopefully the before and after will fit on one line, and then the internals of the brackets, if they don't fit, then they get split. Split into one element per line, and I guess one element per line will work great for things like this giant choice. Minimize diffs. Closing brackets are always dedented. Yeah, it minimizes diffs, unlike the Pip8 style. There's a line length which is like 88 characters for some reason. Does something with empty lines. We don't have to care about that too much. Okay, I think the rest doesn't really apply to grammar. There's something like a very low priority delimiter, so did I skip where it talked about delimiters? Parentheses are optional. Parentheses are removed when the entire statement fits on one line, or if the inner expression doesn't have any delimiters to further split on. Nested parentheses black doesn't removed. Okay. Okay, so delimiter priority looks like an important thing. Oh, I guess that's covered by the line breaks and binary operators. Right, I guess we can take at least the basic algorithm, which is if something fits on the line, then we leave it. Otherwise, we try breaking it up. And even for that, we need to we'll need to set up some scaffolding. So I guess formatting will be methods on the nodes. The nodes already have a format method which returns a representation as a single line string. And then we have format lines, which yield lines of a string representation. And we have a number of columns here. We call format lines anywhere. We do. So in generate rule lines, we call format lines, and we give that method the available space, which basically removes the longest name in the grammar and the separator. So that would be this part, and the rest needs to fit. Okay. There's a to-do here that we don't really need anymore. So to format lines, there's a previous attempt to do this, and that's formatting lines for sequence. Don't think we want to start with sequence. What I guess we do want is to format for precedence. Right, we probably want to know whether to add parentheses around an item or not. Maybe, maybe not. Well, I want to start with something something bit straightforward, and I guess the most straightforward thing would be this choice. So to format lines of a choice, looking at black, we want to first do the single line formatting, and if it fits, then we're done. Otherwise, we're not done when we need to do something else, right? So looking at the diff, this would be wrapped, that would be wrapped, this would be wrapped. Yeah, basically all the long things in the grammar would be wrapped. Now, how would they be wrapped? Maybe the easiest thing we can do is put them in parentheses, just to see we're doing something. And then for each item, we yield from the format lines of that item. So now, well, let's actually look at that in the browser. Compound statement gets split up into this thing, which looks pretty nice. Or pretty nice for a start. I'm missing the separators here, so let's add those next. I'll need to go through each individual line in there and yield each line separately, and I'll need to add that separator to there, which will take 2 of my columns. So how does that work now? I have the separators here. Sure. Looks pretty good. I want to lose the separator on the first line. How to do that? Oh no, I only want the separator on the first line of each item, except on the very first item. So let's have an item index in here and a line index in here. And then if the item index is bigger than 0 and the line index is equal to 0, then the prefix will be the separator. Otherwise, we'll have an empty prefix. Right, so we now have function def, or if statement, or if class def, and so on and so on. I guess this parentheses can be moved a bit down. So for the first item, the prefix will be an open parentheses. Otherwise, the prefix for the first item, first line, will be this choice. Now I can lose this parenthesis here, and I have this kind of formatting. Well, I'm missing a space there. Which is readable. It's different than what the grammar specification uses, which is put this marker on each line, but after an indent. Which is a bit more readable, but we can't really do that with the Sphinx syntax. So this is probably rather good. Let's look how the import statement looks here. There's a bunch of choices. Now this is just too noisy. Maybe I can lose the parentheses altogether. Well, that's not very readable. I think I really want this style here, which is not something Sphinx will let me do with the built-in grammar displays. But I guess more importantly, I want to break the long sub expressions, and I'll need to do that anyway. So that's probably the next step here. Yeah, whenever I have a long sub-expression in there, I'll want to break it up as well. And I guess the next thing to break up is sequences. And sequences will be a bit harder. So I guess what I'll need to do for sequences is find a breakpoint somewhere in the sequence, break it there, and then consider the rest, the subsequences, and if either of them is too long, then break it again. Maybe what I should do is do some kind of debug output here as well. So whenever a line is too long, when it's printed out, here, do this, and that would show up before the diff. all? Is that all the long lines we have in the entire grammar after breaking choices? That is pretty good. I thought this would be more complicated. I want to put the name in here. Just so I know where we are. So in strings, there's this this big repeat. In f-string replacement field, it's all just a sequence. Maybe I should put in the type of the node as well. So I know what we're dealing with. So there's a one or more, a repeat, and there's a sequence. There's a nested choice. That should be pretty easy to break up already. Oh, a lot of these are choices. So I do format lines for the available space, and I end up with lines that are too long. And their choices themselves. It's interesting. So where would I find this primary? Maybe in expressions. I'm writing out. Right thing. So primary is this, and then choice weight. So this should be included in primary. Oh, I didn't. Ah, I see. I didn't refresh. So this line is too long. And that line is a sequence. There's a primary, and after that there's this long choice. How could we break this up in a pleasing way? Maybe we should break up this choice itself. I mean, as the black algorithm says, it'll look at the first outer matching brackets and put that in a separate indented line. So I think brackets are something to look into. If the sequence includes brackets, then we'll want to break those up. many of these include brackets? Well, this definitely includes brackets. There. There and there. Yeah. Anyway, that's breaking up sequences. And for today we're out of time, so I will leave that for later. Hopefully next week everybody will be fresh. Thanks for joining in.